Okay. Hey y'all. Today's lesson is about scatter plots. And so I've already got the vocabulary words for you. Go ahead and copy these down. Bivariate data. That's our weird word, bivariate. So bi meaning two and variate meaning like varies or changing. So bivariate data is data with two variables. And what we've been dealing with commonly are the two variables that we are commonly dealing with are x and y. So bivariate data is data with two variables. A scatter plot shows the relationship between those two variables in ordered pairs. It shows the relationship between those variables in ordered pairs. And so you're going to see a bunch of dots on a coordinate plane. That is a scatter plot, but this time it's talking about the specific variables in the problem. And so what we're going to do is we're going to do some examples. So example 1, construct a scatter plot of the weight of an alligator at various times after hatching. So I've given you a table. So we have our x, the weeks, the independent variable, the number of weeks after hatching, and then the weight of the pounds of the alligator. So 0 weeks after hatching, that just means like right when it hatches, the alligator is 6 pounds. Just like with humans, when you're born, you have a weight. It's not going to be 0, 0. And then after the weeks of the hatching, the different weights that the alligator, and you would think, okay, well, the alligator should grow and gain weight, which is exactly what's going to happen. So to construct a scatter plot, we need to, hey, fancy shoes. We need to label our axes. So our x-axis is the number of weeks. And our y-axis is going to be our weight in pounds. And that's our y variable. So to construct a scatter plot, you are just going to graph these ordered pairs as best you can. And I've already given you your coordinate plane. So 0, 6, 9, 8.6, and so 18, so 15, so 18 will be here, 18, 10, 27, 13.6. So you notice, I mean, it's not going to be exactly linear because the weeks are different. It's going up by 9 weeks each time, but the weight is different. 34, 15, so it's right before 35. 15 is going to be in the middle of 15, 16. 43, 17.2, and then 49, 19.8. All right, so that's how you construct a scatter plot. You take your table of values, your data, your bivariate data. I have weeks and I have weight. So that's bivariate data, and we are organizing it in ordered pairs. So that is how you construct a scatter plot. There are things about scatter plots that you are responsible for knowing. So let me go over a few of those. So in the bottom right here, we have types of associations. There's different types of associations. There are 3 ways a scatter plot could go. This is just an example of a scatter plot. I didn't give you any values. I didn't give you any units, but the x-axis, as the x increases, because again, we're starting at 0, we're increasing, the y is also increasing. Do you see? The x is increasing in number and the y is increasing. So this is called a positive association because the value in the data is moving in a positive kind of direction as a slope. So that would be a positive association. And in this middle one, you can see the x values are increasing because, again, you're starting at 0 and we're going this way in the x. But the y values are decreasing. The y values are decreasing, and this creates a negative association. This data has a negative association because one is increasing, one is going up, one is going down, and that's like a negative number. If you have one positive, one negative, it would be a negative. So both are increasing would be a positive correlation. If one is increasing and one is decreasing, that would be a negative correlation. And in this third one, we just have dots all over the place. I don't know what this data is, but this would be no association or no correlation No association or no correlation because there's no pattern in this data. We can't say what's happening if it's increasing, decreasing. So that would just be no correlation or no association. So it's important for you to know if there's a positive or negative or no correlation association. And then other ways to interpret your scatter plot data would be, okay, so we talked about positive or negative, if it's positive or negative. Maybe it's linear or nonlinear, linear or nonlinear. So if your dots look close to a line, then it would be a linear association. If it looks close, like they're lying in a line. For example, this would be a linear. This one would be linear because they look like they're lying close to a line. Nonlinear means your data looks curved somewhere. It looks curved, so that would be a nonlinear association. And I'll show you an example of a nonlinear association. The last two ways we interpret data are clusters or outliers. Clusters mean you have like a bunch of data close together. A bunch of data that's really close together. So this one, these are all pretty the same distance. This one would not have a cluster. This one would not have a cluster, but there's one on here with a cluster. So a cluster would be like, you see a bunch of dots like all together, and then the others are spread out, so that would be a cluster. Outliers kind of sound like what they are, outliers. So outliers are all alone, and they just stick out. They stick out from the others. They stick out from the others. So an outlier is one that just kind of is like, oh, that dot is very misplaced. And then you would say, okay, that might be an outlier because it's just strange. It's like that day in July when it's really cold and we need our sweatshirts. That would be an outlier. All right, so let's go to the back. Describe the association of the data observed. So the different associations I just talked to you about, whether it's going to be a positive or negative, linear or nonlinear, and cluster outliers. We're going to talk about each of those in these examples. So the first one, A, cost, memory. So if you are buying something with gigabyte memory, the cost of whatever we're buying. So first we need to know what we're talking about. We need to look at the data. So we have our scatter plot, we have dots, and it looks like as our gigabytes increase, as our X increases, our scatter plot, our dots are also increasing. So if both are increasing, then it would be a positive correlation. So this one has a positive, I think I put too many S's in there. Positive association. Okay, so that was the first one, positive, it's positive. So linear, nonlinear. When you look at this, it looks like all the dots are really lying close together, and it could be linear. So this would be a linear association because all the dots are really close to that line. We don't have any that kind of like curve, like this one down here looks like it's curving. And then we need to identify are there any clusters or outliers. So for this, it does look like we have a cluster because we have 1, 2, 3, 4, 5, 6, 7, 8 dots really close together, and then we just have 4 over here. So there's a cluster between 1 and 2 gigabytes of memory. There's a cluster right here between 1 and 2 gigabytes of memory, probably because that's where most people stay, 1 to 2 gigabytes. Very few of us probably need 8 gigabytes. And then we have 2 up here, but because we have 2, we don't really have any outliers in here. Okay. Okay. All right, so B. In this problem, our data, we have time elapsed, so minutes, number of minutes, 5 minutes, 10 minutes, 15 minutes, and then the temperature, Fahrenheit degrees. So the temperature, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50, and 60. So as our X values increase, because our minutes are going from 0 to 40, our dots up here are decreasing. So that means we have a negative association. And negative association because I have one data increasing and one data decreasing. So the next one is it linear or nonlinear? And this one looks like it's pretty linear, because if I were to draw a line, it would follow a straight line. So we have a linear association. And then the next one is, do I have any clusters or outliers? Do I have any clusters or outliers? Well, it looks like these are all pretty evenly spread out. I don't see any clusters. I don't have like a bunch of my ordered pairs close together. And I also don't see any outliers. I don't like if I had a dot right here, 4 and 5 minutes, it would be 10 degrees. That would be an outlier, but I don't have any outliers in this data either. All right, so C, number of pints sold in the day. Now, pints of what, I don't know, but as the days go from 0 days to 20 days, the number of pints that are sold is being charted up here. So these are my two variables, and I want you to see if you can pause it and describe the associations. Is it positive or negative? Is it linear or nonlinear? And does it have any outliers or clusters? Okay. So first, my days are increasing and my number of pints are increasing, so it has a positive association. And it looks like my data actually follows, and I already told you, it follows a curve. It's not linear this time. It looks like it follows a curve, so it's nonlinear behavior, nonlinear association. And then clusters and outliers. Well, if you were to think this is an outlier, it's really not, because that's the way that the behavior of the data is going. It's going to just kind of keep increasing right there. So I would say no outliers. And then I'm kind of curious what you think, if you think this is a cluster right here, or if you said no clusters. 1, 2, 3, 4, 5, 6. So we have 6 dots like between 2 and 8. 1, 2, 3, 4, 5, 6. And then between 8 and 14, we have 1, 2, 3, 4, 5, 6. And so because we have like 6 and 6, now if you said between 2 and 10, 1, 2, 3, 4, 5, 6, 7, 8. We have 8, and then if you said between 10 and 18, 1, 2, 3, 4, 5, 6, we have 6 and 8. So mathematically, there's probably not a cluster, because if you break it up into intervals, there's not one that heavily outweighs the other. Like in this example, we had 8 right here, and then over here we only had 2 and 2. And this was just between 1 to 2 data values. So again, if you spread it out between like 4 or between 6, it's kind of spread out even. If you said cluster, I can understand, but really when you actually count the data values, there's no clusters. Okay? So last one. Describe the association, if any, of the observed data. If an association exists, makes it conjecture. So that's like a prediction or a guess about the winning time in 2020. Okay. So positive or negative as the winning times and the year. So I don't know what sport we're talking about, but we're talking about the Winter Olympic, or just Olympics. So as the years increase, the winning times have decreased. So this would be a negative association. Over the years, people are getting faster. This looks like they all line pretty close together. I'm not seeing a curve, so this would be a linear association. And then, do you see any outliers or do you see any clusters in this data? And I'm not seeing any outliers. Like this one is a little bit lower, but it's not, it doesn't like stick out like, whoa, that one's so low. So no outliers and no clusters, because all this data is really spread out very evenly among our years. And then the last thing asks about the winning time for 2020. So if we were to extend our x-axis, we have 2008, 2012, 2016, and then the next one, what are these going by, 4s? Would be 2020. Where do we think the next data value would be. And I would say it's probably going to be above 46 point something, because it's kind of going like up and down and up and down and up and down. So it might go down and then it might go back up. So I would say like 46.5 or 46.4 seconds. But it needs to be kind of close to this 45. It's not going to be below 46. It's not going to be below 46, and it's not going to be way up here, because consistently it might go up and then down, and this one went down, but then it went back up. So these are the winning times in the Olympics every 4 years for some sport. I don't know. But when it asks to make a conjecture, that's like a prediction or your guess based on the data that you have. All right, we are going to practice more in class.